What will happen to a human in open space without a spacesuit? There is no doubt that they will die. But from what exactly? Will they freeze into an icicle? Explode? Suffocate? Will their blood boil? Will they burn in the sun? There are many theories, all of which have tragic consequences, leading to the death of a person. But what will cause a person to die the quickest? You are on Advaluan. So, imagine you are in open space where it is very cold, minus 271 degrees Celsius. Of course, almost all bodies turn into icicle at such a temperature. In reality, space is neither cold nor hot. It's just neutral. The point is that we perceive temperature thanks to the air that blows around us. In winter, it takes heat away too quickly, and we freeze. In summer, the body, on the contrary, doesn't cool down properly. Vacuum, however, does not conduct or take away heat. This is why the air is pumped out of thermos walls. Vacuum is a perfect heat insulator. In space, although it is not an absolute vacuum, it is very close to it. Therefore, the only way to cool down in space is to slowly release heat in the form of radiation. Thus, a human body will cool down over many hours. Therefore, a person will not freeze, but will only feel a slight chill. Let's look at the opposite effect. You can get a very severe burn or overheat from the sun. Indeed, there is a lot of ultraviolet light that is blocked by the atmosphere on Earth. However, there is no such protective barrier in space, so you can get a burn on exposed parts of your body within 10 seconds. But clothing can completely protect you from this. And as for overheating, even if you absorb all the solar radiation, it will take at least 24 minutes to reach the lethal temperature of 43 degrees Celsius. However, one should not be careless about solar radiation, as it can cause painful burns within a few minutes. This is exactly what happened to Soviet cosmonaut Valery Ryumin when he decided to sunbathe under a transparent porthole. But this won't be a quick enough process to cause death. Many might think that a person will be torn apart due to the pressure difference, but in reality, the pressure difference is only 1 atmosphere, which is not as much as it seems. For example, divers experience an additional atmosphere for every 10 meters of depth, and vice versa. For climbers at the top of Everest, the pressure is only a third of normal, and the difference between Earth and space is the same as inside and outside a car tire. For instance, when parachutist Joseph Kittinger's glove depressurized, his hand swelled to twice its size in about an hour, but returned to normal fairly quickly on the ground. So the body in space will indeed swell, but rather slowly. A person can indeed burst, but for this, a much greater pressure difference is needed. For example, on the Byford Dolphin drilling rig, a hatch in a large decompression chamber for divers, which had 9 atmospheres, was accidentally opened. The people inside died instantly. One literally exploded, and his remains were sucked through the crack of the partially opened hatch. But with a difference of 1 atmosphere, it is not so terrible. Some might think that a person's blood might boil. Indeed, with decreasing pressure, the boiling point of any liquid drops. But even if the outside pressure is 0, there will still be pressure inside the blood vessels. Blood will boil at 46 degrees Celsius, but it is surely at body temperature of 36.6 degrees Celsius, so it will not be hot enough to boil. The last reason is a lack of oxygen. But if you do not burn, freeze, explode, or have your blood boil, can't you hold your breath? No. The pressure in your lungs is high, and the force with which the air will rush out is very great, and you cannot resist it. As a result of a large exhalation, you will lose all oxygen reserves, and you will have about 10 seconds before you lose consciousness. During this time, you can take a couple of reasonable actions aimed at saving yourself. For example, dial 911. It is clear that an oxygen mask will not help either, because if enough oxygen for breathing is forcibly pumped into the lungs, they will burst as well. If you liked the video and want to support the Young Physical channel, then do not forget to subscribe and like the video.